Good afternoon, everybody. Pakistan. Those of you who know me know that I typically don't have a lot of curly braces on my slides. I'm not going to talk too deeply about code and so on. I will really spend first couple of minutes with motivating why we're doing this. Then I will give some outlook of what it is, and then you can try to ask me questions. Let's see how that goes. Last week, I was at the conference and I was sitting there thinking, oh my God, the next speaker who's going to start his presentation with a China speed slide, I'm going to kill him. So please be merciful to me. But at the end of the day, right, this is still the topic. And I just came back from Shanghai Auto Show. And the amazing thing is in China, people don't care about horsepower anymore. You sell the vehicle by gigaflops, right? In Europe, not yet so much. And actually, question is, will this really ever happen here? And I was also talking to a lot of taxi drivers who were still saying they want a good, solid German engineered car. And we're in Germany here, I'm allowed to say this, but obviously this also applies to Japan engineered cars. And also, I think Chinese cars are well engineered these days, but the way how we market them is different, right? And from the point of view of those OEMs that are not yet moving at China speed, the big question is, what is holding us back, right? And I was trying to do a little bit of research on this, and I think everybody here nowadays is living in his own bubble, right? So we look at our telephone all the time, and the telephone's feeding us some information. So we all have our nice little social media bubble. So this is a snapshot of my social media bubble of the last couple of weeks. I like this one. Let's kill some speeds. Yeah. A-Spice only in Germany. It's not even a standard. Yeah. The Museum of Unused Documents. I think that holds a lot of truth. Yeah. And then this was actually from 1st of April, right? So yeah. We've given this some thought, right? And actually, just last night I had dinner with a close friend of mine, and he's working for a large OEM. And when you ask him what he's doing, he's saying like, I work on the right-hand side of the V model, right? And the question is, on the left side, we have all these visions of, requirements and traceability and so on. And on the right-hand side, apparently it's just chaos and mayhem, right? So the big question is there even something like controls chaos maybe? What is the answer? So we don't have the silver bullet, but we've been given this a lot of thoughts, right? So let me spend a couple of minutes, first of all, really from a conceptual point of view, try to find some answers. And yes, then we will come to the technical blueprints. So the V model. When I started with Bosch about 12 years ago, I was a 100% software person. And then people were talking to me about the V model all the time. And at first I thought like, come on, guys, give me a break. And then I realized, okay, this is not going to go away. And apparently there are good reasons why this is not going to go away, right? And one of these things is the SOP. My secret theory, I'm looking at some Bosch colleagues here. Can you lift your sleeve, please? Do you have a tattoo here? My theory is, as a Bosch person, either you have SOP or MVP, but it can't be both, right? So on the other hand, what we're seeing is the need for speed. And I don't know how many discussions I had where people are always like, oh, Tesla, they're so great and they're so fast and they can do everything in 3 minutes. Maybe also not entirely true, right? I think the trick to this is that we need to accept that things are moving at different speeds, right? So we have digital solutions which move very fast, yeah? Maybe not the deeply embedded safety stuff, yeah, but everything that's fun and AI. And then we have the mechatronical side of things, yeah, where things are moving much slower, right? And how do we bring all of this together? Obviously, a lot of this has to do with culture. And then actually, one thing I think that's really important is requirements. right? So I've seen some statistics the other day, for example, that fast-moving OEMs have managed to reduce requirements by about 60%. Yeah, so average car model these days has more than 1 million requirements. And everybody who knows this stuff will tell you there is no way on earth that you can trace this throughout the life cycle. So reducing this and actually switching to new supply models, outcome-based supply models. That is a key thing. Probably boring stuff for the more technical people in the room, but still really important. The other thing is then, of course, systems engineering. How much is good for us, and how can we keep this as lean as possible? Then digital first. We want to be able MVP. We want to be able to try out as early as possible if a customer actually really likes a feature and so on. And then actually to tie all of this together, these cycles moving at different speeds, of course, we need loose coupling. And of course, then we need automation, we need engineering intelligence, we need continuous homologation. And at the end of the day, we really need to find out if people using this stuff. I have a good German car. I really like my car. Apparently, my car has a feature that will park the car automatically. Can I be bothered to go into the basement of my house to pick up the paper manual to tell me where this feature is hidden? No, so I've never used it, right? So that should tell the person who actually invented this feature something, right? So it's all about then measure and learn and then start from the very beginning. So what we did for the last 2 years, working closely with Eclipse, initially was to focus on digital first and loose coupling out of these many things that we believe are important. And what we put together, what we put together is this project, Eclipse AutoWorks, that we're hosting as Digital Auto as an instance that you can use. And here the idea is that you can basically take your SDV idea, you can very rapidly develop it, get feedback, and find out how it would fit into the greater scheme of things. For example, what interfaces are needed to make this fly in a vehicle context. So interfaces are really important. And this is why we've started actually with Covisa VSS. The more technical folks in the room will know this. Obviously, there's many other types of interfaces. We just heard about the SOVD interfaces and so on. The Chinese have their own flavors of interfaces, but at the end of the day, interfaces rule, right? So API first. So this is the starting point for us. And then, of course, we're using a lot of Eclipse projects to actually tie together an application environment that we can very rapidly deploy in. And the result typically then looks like this. This is a project that we did with a German OEM where they basically said, hey, can we have a passenger welcome sequence? The car basically in a very personalized way will welcome you. Yeah, and open the door, adjust the seat, and so on. And surprise, we need to be able to do this in multiple variants, right? So maybe we have one vehicle that only has the door and the seat. Yeah. So we're Jane Smith, and then we have another vehicle that's maybe a right-hand drive that has the full configuration, including lights and HVACs and seats and so on. For the technical people in this room, I'm not showing the code behind this and so on, right? But there are obviously a lot of interesting questions here, right? So for example, do we make the API smart enough to detect whether the vehicle has an open door or not an open door thing? Do we use a static configuration, maybe tied to production data and the VIN, or do we do dynamic service discovery, blah, 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 right? So lots of interesting thing here. And at the end of the day, of course, also this relates to testing and so on. And this is where it starts getting interesting. So this is basically on the technical side what I wanted to talk about today. If we want to support this big picture, right? How can we utilize an Eclipse SDV blueprint powered by Digital Auto to basically help us start upstream, shift left, do prototyping, early stage validation, and eventually move through the flow until we're in the real vehicle. What are the things that we need to put together, right? And this is basically what this idea of this blueprint is. So a lot of this relates to staging. So what I just had shown to you is what we would call a mock-up. Yeah, so the mock-up typically has a very lightweight backend, might have some simulation information in it. Yeah, so we've been working with Dassault systems, with CarMaker, with ANSYS, and so on, to actually interface their systems with a vehicle abstraction layer. This is actually, I think, we're also working on standardization in this space. Those of you who are familiar with virtual vehicle development and simulation, they know FMI, FMU. So this is actually very tightly coupled. We need loosely coupled. So we need to basically take these standards and extend them to add the VHAL, the vehicle hardware abstraction layer, to make this work. Then we have in the next stage the virtual vehicle. Depending on who you talk to, this is just around the corner and will happen tomorrow, or no, it's so super sophisticated and complex, we will never have all of the vehicle ECUs on level 5 fully integrated in timesync. But at the end of the day, it's still basically, I think, something that people see as a key shift left strategy, right? Then, of course, we have the topic of testing this in real life hardware setups, desktop type of simulations. And then at the end of the day, we have going from hill then to the real test vehicles and so on, right? And this is actually a complex flow, yeah, where we have artifacts like early on I was talking about this passenger welcome sequence. The algorithm is not that complicated. Detect proximity, open door, adjust seat, adjust language settings, get user preferences from the cloud for this, and so on, right? So I want to be able to take this algorithm and basically use it already in the mockup against the real API, yeah? And then step by step, I want to basically have the algorithm flowing through the stages, ideally without much change, okay? And yeah, that means I want to be able to actually update this algorithm on the target environment and so on. So that means basically we need to be able to get a holistic view of our functionality as it is flowing through these different stages. Then, of course, it also means that we need to understand the stages themselves. And this is basically where for us now it becomes a technical blueprint. So we need to be able to combine the agile with the first time right side of things. We see the vehicle hardware abstraction layer as a key ingredient to this, not only for technical decoupling, but also for organizational decoupling, right? And then basically we have functionality basically going through these stages. So what are we using here on the Eclipse side? Of course, first and foremost, we have Eclipse AutoWorks, which is our project, which is the umbrella around everything. Then we have Eclipse Velocitas, which we're running as the north of the VHAL environment. And we have, of course, Cuxa supporting Covisa VFS. Then we've started to work with Eclipse DUT for combining different test elements in a more loosely coupled way. Yeah, so we're talking about hard real-time sync and so on here, but it's still a good way of stitching end-to-end functionality together. And then this morning we heard a lot about Eclipse S Core or Score. I seem to be getting mixed messages here, whether it's with or without a hyphen. But anyway, somebody's looking at me. She is going to kill me after all. But basically, yeah, this is going to be an interesting thing happening as we learned at the moment. Yeah, so we would be very keen to then also incorporate this here once it's tangible. And then Christian told me to also add open hardware, which I did. So that's more hey, this is something we want to look into in the future. Okay. And then, of course, yeah, we need the blueprint to basically support us through the stages. So, for example, here we have one side of the blueprint, which is more on the functional mock-up side of things, which will basically result in the example I was showing to you earlier on, where I can see the passenger welcome sequence end to end, how it's working out, right? And then in the next stage, basically, we have the more detailed breakdown here, where we start, for example, mapping this to real test hardware, to real ECUs, using realistic automotive onboard middleware, for example, from good vendors in this space. And yeah, um, this is important for us that we understand kind of like the blueprints in these different stages and how we can then actually focus on as seamlessly as possible to basically guide application software and application software changes through this. Because at the end of the day, we're not in the business of creating the most beautiful middleware. We want to be in the business of actually creating differentiating functionality. And that's why it's important to manage this flow. And this is where I think really this joint approach with the Eclipse SDV blueprint is becoming very important for us. I'm not gonna explain this in much detail. This is all online. This is all documented. You can go out there, you can use it, you can try it out. It's fairly out of the box. One key thing, yeah, Christian, when it comes to hardware, is that of course we also want to be able to support different types of EE patterns, yeah, as a deployment target. So we have one system that you see on this image that we've developed together with Bosch colleagues and ETAS colleagues. We have the ambition to also make all of this available as out of the box as possible in the Digital Auto Garage, where we're currently working with Sarah and the team on setting up the Eclipse SDV lab. Don't quote us on LinkedIn yet. This is not fully official, but hopefully we'll get there. Yeah. And yeah, then basically have a fully fledged vehicle that basically has the test hardware in it, that has the Eclipse blueprint in it, that we can then use to do a lot of functional innovation. Yeah. And this was actually something yep, that just also happened last week. This is from Ansgar Meroth and Marco Wagner and so on at the Hochschule Heilbronn, who basically put together this nice-looking EE architecture, starting with the Digital Auto starter kit that we put together, and actually making sure that this also works nicely together with the playground, the AutoWorks project. So you can basically take your prototype out of the cloud development environment and deploy it onto this board here. And then they're currently working also on enabling, for example, extension packs for different type of functionalities that can be plugged in, connected either via Ethernet or via CAN. All right, that's it. So I really wanted to motivate this. This was important to me to say we're not just only doing this out of fun, but we're doing this because we think we need answers to this China speed question. And these answers are not only technical, they're also cultural, organizational, and so on. And all of this basically needs to work together. And this is where we think this new Digital Auto blueprint at Eclipse SDV is going to be really helpful. So with this, I'm at the end of the presentation. Nobody has tried to kill me. I appreciate that. Thank you. Are there any questions?
So, any question from the audience? So, who wants to participate in this blueprint?
how far away is this from your reality? I mean, like this morning we were talking about S-core and the nitty-gritties of like operating system development and so on. Do you see these topics that I was talking about as an issue in your organization, even if you're not directly working on this?
Still, no, it's very tough. Okay, think like the topic is indeed of interest. We need to find a better way of collaborating at the feeling.
We will do that.
So, as you know, we have a project that is a project of projects. It's the Eclipse Blueprint. So differently from Esker. So every blueprint is one very specific use case, solves one very specific use case. And I think that's an excellent way to start hands-on on it. And could be a good opportunity for a hack challenge.
Definitely.
Because we have a hackathon coming up. So
in Berlin.
And
so, Porto, that's awesome.
So you can choose, depending on where you get along. So thanks a lot.
Thanks, Sarah.
Thanks.
Thanks for having me.